Hi friends, welcome to all. In this video we are going to see the packet tracer activity, configure VLANs, VTP and DTP. Here we can see our addressing table. Right, now we will come to our objectives. In part 1 we will configure and verify DTP. In part 2 configure and verify VTP. We will go through the background. As the number of switches in a network increases, the administration necessary to manage the VLANs and trunks can be challenging. To ease some of the VLAN and trunking configurations, VLAN trunking protocol, that is called VTP, allows a network administration to automate the management of VLANs. Trunk negotiation between network devices is managed by the dynamic trunking protocol, that is called DTP, and is automatically enabled on a Catalyst 2960 and Catalyst 3560 switches. In this activity we will configure trunk links between the switches. We will configure a VTP server and a VTP clients in the same VTP domain. We will also observe the VTP behavior when a switch is in VTP transparent mode. We will assign ports to VLANs and verify end-to-end connectivity with the same VLAN. We will come to part 1, configure and verify DTP. In part 1 we will configure trunk links among the switches and we will configure VLAN 999 as the native VLAN. Step 1, verify VLAN configuration. Verify the configured VLANs on the switches. On S1, click the CLI tab. At the prompt, enter enable and enter the show VLAN brief command to verify the configured VLANs on S1. Right, so we are going to give this command, and here itself they given the output. Right, so we will do this now. Coming to the switch S1, CLI enable. Here we are going to give a show VLAN brief, and here we can see the details. These are the default VLAN, and here we can see the VLAN created 99 and 999. Next is repeat step A on S2 and S3. What VLANs are configured on the switches? Right, so we will check that. Coming to S2, CLI enable. Here we are going to give a show VLAN brief, and here we can see that 2 VLAN created 99 and 999. Right, coming to S3, CLI enable show VLAN brief. Yes, here also we can see the VLANs. So VLANs 99 and 999 are configured on all the switches S1, S2 and S3. Now we will come to step 2, configure trunks on S1, S2 and S3. So dynamic trunking protocol, that is called DTP, manages the trunk links between Cisco switches. Currently all the switch ports are in the default trunking mode, which is dynamic auto. In this step we will change the trunking mode to dynamic desirable for the link between switches S1 and S2. For the link between switches S1 and S3, the link will be set as a static trunk. Right, so use VLAN 999 as the native VLAN in this topology. Coming to A, on S1 configure the trunk link to dynamic desirable on the gigabit Ethernet 0/1 interface. So here we can see, coming to topology, the switch S1, and this is the interface gigabit Ethernet 0/1. So for this interface we are going to configure the mode, switch port mode, as a dynamic desirable. As per the instruction we will configure on S1. Right, so here we will give a configure terminal and we will go to the interface gigabit Ethernet 0/1. And here we are going to give switch port mode as dynamic desirable. Yes. Now we will come to B. For the trunk link between S1 and S3, configure a static trunk link on the gigabit Ethernet 0/2 interface. So here we can see that S1 and S3 So here the interfaces gigabit Ethernet 0/2. Here we are going to configure the mode as trunk. Yes, so we will come to S1 first, right? So we will exit from here and we will go to the interface gigabit Ethernet 0/2, and here we will give the mode as a trunk. Yes. Now we will go to S3 CLI, right? Configure terminal, and we will go to the interface gigabit Ethernet 0/2, and here we will give the switch port mode as a trunk. Now we will come to C. Verify trunking is enabled on all the switches using the show interfaces trunk command. So we have to give this command show interfaces trunk, and we can see it's trunking. Yes, gigabit Ethernet 0/1 and gigabit Ethernet 0/2 is trunking on the device S1, right? So they given the output here itself, right? Coming to S1, right? So here we are going to give a show interfaces trunk, and here we can see the details. Yes, here we have a question: what is the native VLAN for this trunk currently? Yes, here we can see that native VLAN is VLAN 1. Now we will come to D. Configure VLAN 999 as the native VLAN for the trunk links on S1. So here we can see that interface or range gigabit Ethernet 0/1 till 2. We are going to give the native VLAN as a 999, right? So here we are going to give that. Coming to the configuration on S1, right? Here we are going to configure terminal, and we will go to the interface as a range because we need two interfaces on S1, that is gigabit Ethernet 0/1 and 2. So gigabit Ethernet 0/1-2, and here we are going to give the switch port trunk native VLAN as 999. Yes. Next is what messages did you receive on S1? How do you correct it? Yes, here we can see that we got a message, a native VLAN mismatch. Native VLAN mismatch discovered on gigabit Ethernet 0/2 999 with the S3, also with the S2. Here we can see that. Here we can see that. So we can correct it with the native VLAN mismatch. Configure VLAN 999 as the native VLAN on S2 and S3 also. Now we will come to E. On S2 and S3, configure VLAN 999 as the native VLAN. Right, we will do this. First of all, we will come to S2, and here for the interface gigabit Ethernet 0/1, we have to configure this native VLAN 999, right? Yes, here also we can see that inconsistency. So enable configure terminal, and we will go to the interface gigabit Ethernet 0/2, and here we are going to give a switch port a trunk native VLAN as 999. Yes. Now we will do it on S3 on the interface gigabit Ethernet 0/2. Coming to S3. Right, so we will go to the interface gigabit Ethernet 0/2, and we have to give a switch port trunk native VLAN 999, and here we can see the message: unblock consistent port, unblocking gigabit Ethernet 0/2 on VLAN 1, port consistency restored. Yes. Now we will come to the next F. Verify trunking is successfully configured on all the switches. You should be able to ping one switch from another switch in the topology using the IP addresses configured on the SVI. Right. Now we will verify this trunk on all the switches. Coming to S2, show interfaces trunk, and here we can see that. Yes, native VLAN 999. Coming to S1, show interfaces trunk. Here we can see that. Yes, and on S3 show interfaces trunk. Yes. Now we can ping from any one switch to another switch, so we will get the IP address of S2, right? I'm going to copy this address. I'm going to ping from S1 CLI, right here we will ping to the next is here. We can see success rate is 100%. Now we will come to part 2, configure and verify VTP. S1 will be configured as the VTP server and S2 will be configured as the VTP clients. All the switches will be configured to be in the VTP domain ccna and use the VTP password Cisco. So VLANs can be created on the VTP server and distributed to other switches in the VTP domain. In this part, we will create 3 VLANs on the VTP server S1. These VLANs will be distributed to S2 using VTP. Observe how the transparent VTP mode behaves. First of all, we will come to step 1, configure S1 as VTP server. So configure S1 as the VTP server in the ccna domain with the password Cisco. So configure S1 as a VTP server. Here is our command VTP mod server. Then configure ccna as the VTP domain name. Here we can see VTP domain ccna. Then configure Cisco as the VTP password Cisco, right? So we will configure this. Coming to S1 CLI, right? So we'll give a configure terminal and we'll give a VTP mode is a server, right? Now we will set the domain VTP domain as a ccna. It's case sensitive, not case sensitive, but for scoring the packet trace or score we must give in caps ccna, right? So next is a VTP password Cisco, right? Now we will come to step 2, verify VTP on S1. Use the show VTP status command on the switches to confirm that the VTP mode and domain are configured correctly. So we have to give this message and we get this output, right? So we will try this. Coming to S1, right here we are going to give show VTP status and here we can see that VTP operating mode is server and we can see VTP domain name ccna. Next is to verify the VTP password, use the show VTP password command. So we have to give this a show VTP password and we can see the VTP password, right? So coming to S1, here we can give a show VTP password. Here we can see what the password what we set. Now we will come to step 3, add S2 and S3 to the VTP domain. So before S2 and S3 will accept VTP advertisements from S1, they must belong to the same VTP domain, right? That means whatever we given in S1, so that same VTP domain we have to give on S2 and S3. So configure S2 and S3 as VTP clients with the ccna as the VTP domain name and Cisco as the VTP password. So remember that VTP domain names are case sensitive, exactly. So we given this ccna in caps in switch 1, so same this VTP domain we have to give in caps on other devices, here S2 and S3. We will come to a configure S2 as a VTP client in the ccna VTP domain with the VTP password Cisco. So here we can see that VTP mode client, VTP domain ccna and VTP password Cisco. So we will configure this now. Coming to S2 CLI, right? Enable configure terminal and here we are going to configure VTP mode as client and we'll give a VTP domain as ccna and VTP password as a Cisco. Next is to verify the VTP password, use the show VTP password command. Yes, so we will come to S2. Here we can give a show VTP status also, and here we can see that operating mode is client and domain name is ccna. Now we will give show VTP password, and here we can see the password. Now we will come to C, configure S3 to be in the ccna VTP domain with the VTP password Cisco. Switch S3 will be stay in a VTP transparent mode. Okay, right, here they mention a transparent mode, right? VTP domain ccna VTP password Cisco. So this is what we are going to do now, and then enter show VTP status command on all the switches to answer the following questions. Right, before that we will configure on S3. Coming to S3 CLI, right, enable configure terminal, and here we are going to set the VTP domain ccna, and here VTP password as Cisco. Also we can check the password or even show VTP status, show VTP status. So here we can see the VTP operating mode is transparent. Yes, and here we can see VTP domain name is ccna, and also we are going to check show VTP password. Yes. Next is enter show VTP status command on all the switches to answer the following questions. We will read the question. Notice that the configuration revision number is 0 on all 3 switches. Explain. Right, so we will check that on all the switches. Coming to S2, show VTP status, and here we can see that configuration revision is 0. Yes. Coming to S1, enable show VTP status. Here also we can see configuration revision is 0. Coming to S3 CLI, show VTP status. Here also we can see configuration revision 0. Yes, here we can see initially this configuration revision number is 0. The configuration revision number increments by 1 every time a VLAN when added or deleted or modified. No additional configurations have been made to VLANs on any of the switches. Now we will come to step 4, create more VLANs on S1. So on S1, create VLAN 10 and name it red. Yes, here we can see the command. Create VLAN 20 and 30 according to the table below. Here we can see that 20 with the VLAN name blue and 30 with the VLAN name yellow. Right, so we will we will create these VLANs on S1. Coming to S1 CLI, right, configure terminal. We will create VLAN 10. Yes, and we will name as red. We'll create VLAN 20, name as blue. VLAN 30, name as yellow. Oops. Right. Now we will come to C, verify the addition of the new VLANs. Enter show VLAN brief at the privileged exit mode. Which VLANs are configured on S1? Right, we will verify that. Coming to S1 CLI, right, here we are going to check show VLAN brief, and we can see the details here. Yes, here we can see default VLAN 1, then we can see 10, 20, 30, 99. Also we can see this triple line. Right, now we will go to D, confirm configuration changes using the show VTP status command on S1 and S2 to confirm that the VTP mode and the domain are configured correctly. Output for S2 is shown here. So here we can see that all the details of show VTP status, and here we can see that the configuration revision now is 6. Coming to S1 CLI, show VTP status. Here we can see that yes, VTP configuration revision is 6, right. Coming to S2 CLI, show VTP status. Here also we can see that configuration revision now is 6 and all other details. Next is how many VLANs are configured on S2. Does S2 have the same VLANs as S1? Explain. Right, so we will check that on S2 show VLAN brief, and here we can see all the VLANs from S1 10, 20, 30, 99 and 999. Yes, so S2 also has 10 VLANs, the same number as S1, because S1 is the VTP server and S2 is a VTP client in the ccna domain. So S2 has received the VLANs information from S1, so that's why it shows all these VLANs here. Now we will come to step 5. Observe VTP transparent mode. S3 is currently configured as VTP transparent mode. Exactly. So use show VTP status command to answer the following questions. So just we will go through the question. How many VLANs are configured on S3 currently? What is the configuration revision number? Explain your answer. So how would you change the number of VLANs on S3? And right, so these are the two questions. So we will check the VTP status. Coming to S3, enable, here we are going to check show VTP status, and here we can see that yes, configuration revision is 0 and VTP operating mode is transparent. Also here we can see the number of existing VLANs are 7. Yes, so currently there are 7 VLANs on S3. The configuration revision number also we have seen it's 0 because S3 is in a transparent mode and VLAN configurations have not been changed since switch startup. Yes, here we have seen the next question. How would you change the number of VLANs on S3? Yeah, obviously, because we know that our S3 is in a transparent mode, so that it will not implement the VLAN information from the VTP server, that means from the device S1. So all of the VLANs changes either need to be configured manually, or S3 can be changed to a VTP client from this transparent mode to implement the VLAN information from the VTP server, I mean from the device S1. So here next is a change VTP mode to client on S3. Right, so we will do that. S3 configure terminal. Here we are going to make VTP mode as client. Yes, so use show commands to verify the changes on VTP mode. How many VLANs exist on S3 now? Right, we will check that. So show, here we can give a VTP status, and here we can see the details. Now configuration revision is 6, and here we can see the number of existing VLANs are 10. VTP domain name is ccna, and we can see the operating mode is client. We can check that using show VLAN brief. Yes, here we can see the VLAN from the switch 1. They given a note here. VTP advertisements are flooded throughout the management domain every 5 minutes or whenever a change occurs in VLAN configurations. To accelerate this process, you can switch between real-time mode and simulation mode until the next round of updates. Right, however, you may have to do this multiple times because this will only forward packet tracer's clock by 10 seconds each time. Alternatively, we can change one of the client switches to transparent mode and then back to client mode. Right. Now we will come to step 6, assign VLANs to ports. Use the switch port mode access command to set access mode for the access links. Use the switch port access VLAN ID command to assign a VLAN to an access port. Here we can see the details, ports and its VLAN. Here we can see that, then the networks. Right, so here assign VLANs to ports on S2 using assignments from the table above. Here we can see that S2 interface or range of fast Ethernet 0/1 till 8. So switch port mode access, switch port access VLAN 10. So according to this table, we can assign these VLANs to ports. Yes, first of all, we'll do it on S2 CLI. Enable configure terminal. We'll go to the interface range of interfaces fast Ethernet 0/1 till 8, and we will give a switch port mode access, and we will assign the VLAN switch port access VLAN 10. Right, now we will go to the interface or range fast Ethernet 0/9 till 16. Right, here we'll give a switch port mode access and a switch port access VLAN 20. Also we will go to the interface or range of fast Ethernet 0/17 till 24 and switch port mode access VLAN 30. Yes. Now we will come to B, assign VLANs to ports on S3 using assignment from the table above. Yes, here we can see that. Yes, it's almost the same like on S2 how we assigned. Coming to S3 CLI, enable configure terminal. We will go to the interface range fast Ethernet 0/1 till 8 and switch port mode access VLAN 10. Right, now we will go to the interface range fast Ethernet 0/9 till 16, switch port access. We have to give the mode switch port mode access and switch port access VLAN 20. And now we will go to the interfaces fast Ethernet 0/17 till 24 and switch port mode access and switch port access VLAN 30. Right. Now we will come to step 7, verify end-to-end connectivity. From PC 0 ping PC 5, from PC 1 ping PC 4, from PC 2 ping PC 3. Yes, we will do this, we will verify this connectivity now. First of all, we will ping from PC 0 to PC 5. So we will get the IP address of PC 5 using command prompt ipconfig. Yes, here it is. We'll copy this address. Coming to PC 0, desktop command prompt ping to this PC. Yes, we are getting the replay. Now we will ping from PC 1 to PC 4, desktop command prompt ping to the PC. Here the address is at 20.2. Yes, we are getting the replay. Now we will come to PC 2 and we will ping to PC 3. Ping to PC 3. PC 3 address is 30.2. Yes, we are getting the replay. Yes, that's all in this packet tracer activity. But when you see this completion status, here we can see it shows only 91%. So here once we comes to this check results, so here we can see assessment item. Here we can see on the device S1, the interface gigabit Ethernet 0/1, the port mode is incorrect. And here we can see on S2 gigabit Ethernet 0/1, port mode is incorrect. So these are the two problems it shows here. But according to our packet tracer activity, we completed all the configurations successfully, and finally we verified end-to-end connectivity also. But still, if you like to complete fully, you can do it, but it is not belongs to this packet tracer activity. Here the problem shows on the interface gigabit Ethernet 0/1 on S1 and S2. So these are trunk port. Once we convert to access port, here we can see it becomes the completion status becomes 100%. But according to our packet tracer activity, we should not do that. Not only with the packet tracer activity, according to the concept also, we should not change this mode to access. Just I would like to show that configuration here for the completion of this packet tracer activity. So coming to S2, enable configure terminal, we have to go to the interface gigabit Ethernet 0/1. Here we are going to make the switch port mode as access. Now here we can see the percentage 95. Now we will come to S1, CLI, enable configure terminal. We will go to the interface gigabit Ethernet 0/1 and switch port mode access. Now here we can see the completion status is 100%. As I said earlier, we should not do that, so I am going to convert this switch port mode as a trunk. Yes, and on S2, CLI, here also we are going to give a switch port mode trunk, and we are going to check the right, coming to show interface trunk, and here we can see that yes, now we can see we are back to the completion status 91%. Well, my dear friends, if you have any doubt, please comment below. Also, if you like my video, give a thumb, and once again, don't forget to subscribe the channel so that you will get latest uploading video info into your Gmail. Thank you.